Hello, everyone. Thank you for joining us for BHL Day 2021, Reflections in Crises, presented as part of the 2021 BHL Annual Meeting. I'm Connie Rinaldo, Chair of the BHL Executive Committee, and it's my pleasure to welcome you today on behalf of all of us at the Biodiversity Heritage Library. Today's program will include 3 sessions, each reflecting on BHL's roles in addressing different crises facing our planet, including the biodiversity crisis, COVID-19, and systemic racism in natural history collections. We'll open with a keynote from Dr. Ian Owens entitled Biodiversity at a Tipping Point, with questions at the end of the talk. Then we'll have a 30-minute break from 1 to 1:30 UTC, followed by a 2-hour partners reflection panel from 1:30 to 3:30 UTC, again with questions. This panel is called Finding Opportunities During a Global Pandemic, featuring representatives from the BHL partner institutions. That panel will be followed with another 30-minute break from 3:30 to 4 UTC. Finally, at 4 p.m. UTC, we'll begin our final session, a closing keynote from Lydia Ponce de la Vega entitled Decolonizing Strategies for an Equitable Biodiversity Heritage Library. Before we begin, I have a few logistical things to go over. The program is being recorded. Recordings will be made available on the BHL Day event page. You can see a link to that page in the chat. Closed captioning has been enabled. You may adjust your settings for the closed captioning at the bottom of your screen. Attendees, your video and audio have been turned off. Please use the Q&A feature to submit questions for the speakers. We will address questions during the discussion period at the end of each session. At this time, it's my pleasure to introduce our opening keynote speaker, Dr. Ian Owens. Ian is Deputy Director at the Smithsonian's National Museum of Natural History with responsibilities spanning collections, research, exhibitions, education, and operations. Prior to joining the Smithsonian in January 2019, Ian was Director of Science at the Natural History Museum in London, where he led a number of major initiatives in digital collections. In 2016, Ian was the keynote speaker for the 10th anniversary BHL Biodiversity Heritage Library annual meeting. It's great to have him back for the 15th anniversary. From July 2021, Ian will join the Cornell Laboratory of Ornithology as Executive Director and as a professor in the Department of Ecology and Evolution at Cornell University. Thank you for joining us today, Ian, to speak more about biodiversity at a tipping point.
Thank you, Connie, for that warm introduction. It seems strange, I suppose, to be talking to you now through Zoom rather than, 5 years ago, being in the Flett Lecture Theatre at London, NHM. Hopefully in the years to come, we'll be combining those two things. Hopefully some of us will be together in a room, being able to celebrate BHL, but we'll also be using this sort of technology to be able to allow people to participate from all over the world. So let me share some slides here. Hopefully you can all see that screen there. As Connie said, today I'd like to talk to you about biodiversity at a tipping point. As my opening slide here is the image. I've chosen one of my favorite pictures that I have hanging on my wall in the kitchen. This is a picture by a famous North American artist called Charlie Harper. And this is his picture of the mystery of the missing migrants. And you'll hear why this is relevant as we go through this talk. Charlie Harper here is effectively showing the birds that are declining across North America over the last couple of decades. So today, as Connie says, I know the day has got a series of talks about different aspects of crisis. In this talk, I'd like to entwine those a little bit, although I will mostly be looking through the lens of biodiversity. I think at the moment, it's almost impossible to look through any one of these lenses alone. And maybe that's one of the things that's happened to us over the last year, that we've all become more conscious of how humanity, the environment, and social changes interact. So I will actually be structuring my talk about three different types of tipping point. I'll start off obviously talking about the environment and particularly biodiversity tipping points. I'll then move on to talking about technology, often digital computational technology, but others as well, including genomics and citizen science and so on. And then I'll close, coming close to what you'll be talking about later today, talking about tipping points in society. And that's touching on both the COVID experience that we've all had, broader aspects of social activism, and then race and decolonization at the end. And what my overall thesis will be is that now we need to be able to consider these three different types of tipping points simultaneously when we're thinking about something like biodiversity. At the very end of this, I will try to reflect back on what I think that these three different types of tipping point mean for BHL in particular. So let's take the first of these three different types of tipping point, environmental tipping points. My favorite example, if you like, of this is this graph on the left here. Hopefully many of you have heard about what people sometimes call the great insect decline or the insect apocalypse. The graph on the left here is the data, at least, that started this debate recently. This is a paper published a couple of years ago in PLOS One that showed the results of a particular citizen science project in Germany that demonstrated that over the last approximately 3 decades, there'd been a catastrophic decline in the number of insects that were being recorded in a number of sites across Germany by this citizen science project. I think there's a few things that are really interesting about this. The first is the biological or the data impact, which is that this is a massive decline. You can see from the title of the paper at the bottom of the screen here that this paper was recording a 75% decline in flying insects over about a 30-year period. So that would translate to approximately a 20% decline each decade, a catastrophic decline. There are other things that are interesting about this as well. This paper really, I would say, really set off a pulse of concern, not just across scientists, who, to be honest, were already thinking about this sort of thing, but also across broader society and also across politicians. And that really led to an impact on policy and investment and so on. If you look on the right-hand side of the screen here, this is the front page, the title, if you like, the glossy sheet on the top of the New York Times from about the same period. So in other words, a relatively restricted citizen science project in Germany eventually became the front page of the New York Times in the weekend supplement. And inside this magazine, there was a multiple page article with lots of pictures and a lot of analysis and a lot of interviews, all about the insect apocalypse, as they called it, but more broadly about biodiversity declines. This is what I think of as a tipping point. This wasn't just a tipping point with respect to the potential decline in biodiversity, but this was a tipping point in how people started to think about that and communicate it in communities that previously weren't thinking about insect declines. This paper and this coverage eventually led to major investment in environmental monitoring across Europe. Now, if one were to go back and say, what are the actual results of insect declines? Now, of course, many of you will know it's a little more complex than this, as is often the case. It's probably the case that the declines are perhaps around 10% per decade, and there are subtle differences between different groups of invertebrates and so on. However, the overall impression has been that there have indeed been these very substantial declines in insect populations that were not receiving full attention before and have now become the major focus of continental scale investment in science. I would say this is a great example of a tipping point. The point about this thing is that that insect study, that relatively limited German study, citizen science study, was actually demonstrating in a really clear way a much broader phenomenon. Here's another big study of, this is a continental-wide study of changes in biodiversity in one particular group, birds. As you've already heard from Connie, I can't possibly pretend to be unbiased in the groups that I'm going to use in this study. I'll often be using birds as an example. Partly, of course, because I love birds so much, but partly also because there's been a lot of work done on birds on this type of thing because they can be surveyed at such a large scale. What this study here was doing, the graph on the left here shows the results of a multiple data source study, changes in bird abundance across the continent of North America. This brought together data from surveys, from radar studies, and from citizen science projects to demonstrate that in total, there's been about 3 billion birds lost in North America over the last couple of decades. And again, the interesting thing about this was not just that this brought together a vast array of data to try and give a quantitative estimate of the amount of biodiversity lost in a very short period of time, and to demonstrate about 3 billion birds. It was also the way that this was picked up, particularly in the North American media. Again, on the right there, you can see some headlines from the New York Times demonstrating that this didn't just show up once in that paper. This was used as a theme for a number of months subsequently, talking about what are birds telling us about a broader biodiversity crisis and what does it mean to lose 3 billion birds. The broader perspective here is obviously the Anthropocene. The paper on insects, the subsequent analyses on birds and so on, were all demonstrating a much broader pattern. And that's demonstrated on the left here in one of the papers that came out of the most recent IPBES report and has subsequently been used by the World Wildlife Fund as well. And what this shows in red there shows you the proportion of species in different groups of organisms that are currently considered threatened by extinction. And the striking thing about this is how many of them now are recording very high rates of potential threat. All of this is demonstrating that we are potentially approaching a tipping point with respect to the number of organisms, the proportion of organisms that are threatened in some of these groups. And of course, each one of these types of reports is always accompanied by the warning of, we still don't really know enough about which of these species is threatened to know that this is really accurate. It could be even worse than this. I find the graph on the right here really sobering. This shows the number of extinctions that have taken place in the last few hundred years, starting in the 1500s and going all the way through to the present time. And you can see for different groups of organism, again, the number of extinctions are accelerating enormously. Now, lots of people often say to this, well, aren't extinctions normal? And should we be worried about this? I think this graph does a great job of illustrating how much higher extinctions are now than they ever have been in the past in terms of short periods of time. If you look at that, kind of faded line near the bottom there, that's the background rate of extinction. So we can say that the current rates of extinction are probably between 100 and 1,000 times as high as we would normally expect them to be. Again, that's another one of the reasons that people think we're approaching a tipping point with respect to biodiversity. Throughout this talk, though, I don't want to just give the impression that everything is negative. I would say, as a biodiversity scientist, that we are in a crisis with respect to biodiversity loss and our response to that. And we have to take immediate action for that. However, it's been really exciting over the last few years to see colleagues start to figure out, well, what can we do about that? What does it mean to take immediate action? And this is one of the papers that has been doing this. What the graph on the left here shows is this along the x-axis, the horizontal axis, this shows change over time. So over on the left would be back in the 1970s, over on the right would be going into the future, 2100. What each of these curves here shows is that what might happen with respect to biodiversity. So if you see at the beginning, that dark curve at the beginning, that shows what's happened in the past. That's the historical curve. And you can see that huge decline in biodiversity even between 1970 and 2010. What those three graphs lines show after that, however, is what might happen in the future. Now, of course, one of these lines refers to business as usual. And that's that dark grey line right at the bottom there. And you can see that that at least continues the decline in historical decline in biodiversity that's been seen before. So that continues to go down to extremely low rates of biodiversity. The other two lines, however, consider what would happen if there was global action on the environment. The amber, the orange line there, shows what would happen with increased conservation efforts. So that would be things like replanting and protecting regions and so on. And the green lines shows what would happen if you combine those sorts of kind of tree replanting, protection type efforts, and you combine that with changes to consumption, particularly shifting towards a more sustainable agricultural system where we're using, in particular, more vegetable proteins and so on. Now, the fascinating thing for this is demonstrating in that most optimistic scenario, the green line there, where you've got conservation efforts with more sustainable production and consumption, you're starting to bend the curve or kind of push back the decline by about 2050. To me, this is one of the most positive things that I've seen in a scientific paper, that we can make a difference within decades if there's a sufficient effort to do so. To me, therefore, this is another sort of tipping point. This wasn't just a mental tipping point for me seeing this, realizing there was this sort of hope. It's also a tipping point in demonstrating that even the precipitate declines we've seen over the last few years could potentially be reversed. We could bend back those tipping points if there's a sufficient effort and will to do that. So now let's turn to the second type of tipping point that I mentioned at the beginning here, technology tipping points. How are these affecting how we understand biodiversity? Here I would say that in the same way as there has been a huge decline in biodiversity, there has been a huge advances over the last few years in the types of technologies that are available for us understanding biodiversity and trying to map better solutions, trying to figure out how to bend that curve. The first one, which you'll probably be most familiar with, or very familiar with, is mass digitization. Now across many museums around the world and botanic gardens and so on, there are lots of efforts to do large-scale digitization of museum specimens, in this case herbarium sheets you can see here. And you'll have all noticed how often this boils down to actually trying to extract information from the labels associated with the sheets or with the specimens and so on. This is now a big industry, and it's really accelerating how much historical information we have on the distribution and occurrence of lots of different sorts of organisms. And of course, this is exactly the sort of area where BHL is already linking in strongly to this sort of effort. The next stage, of course, of this is to actually link this information together. One concept that's popular at the moment in this area is the extended specimen concept. This is shown on the left-hand side here, where you have physical specimens in that little circle right at the bottom there, and you can see the different sorts of information going out from this. I think this points strongly to BHL type concepts, because you're taking physical specimens, be that an insect, or be that a book, or be that an illustration, and linking that with lots of other sorts of information. So you eventually create this web of knowledge that you can pull on when you're trying to do a study. The picture on the right here illustrates how this might be applied to a particular type of collection, and the number of sorts of samples that eventually become connected to each other. I think BHL has led the world in doing this for printed materials. And I think the challenge now is for us to do this across different types of material. And of course, what this is pointing to now is the aggregation of biodiversity data. The graph on the left here, the picture on the left here, which I hope all of you have seen, possibly used in your own talks, is a recent screen grab of the GBIF database, showing the geographical occurrence of different sorts of organisms across time. I think one of the exciting things now is that there isn't just the overall GBIF database, which has tended to focus previously on observational records. GBIF is now working very closely with a series of other major data aggregators and projects to bring specimens and so on even deeper into this matrix. I'm thinking there particularly of iDigBio in North America, ALA or Atlas of Living Australia in the Australian continent, and of course in Europe, the emerging DISCO project. I think that this is going to be, as these things now come together and apply, if you like, the extended specimen concept, I think this is really going to accelerate the use of specimen type data in large biodiversity studies. But digital records aren't the only way, and computational records aren't the only way in which technology is advancing with respect to biodiversity. There are also huge advances with respect to genomics. I would say here, particularly environmental genomics is going to be very important. And that's the idea of being able to use small environmental samples, just such as on the left here, a small sample from a water source, to be able to figure out which species are in there by effectively doing a sort of form of meta-barcoding to be able to see the DNA that's in that sample. The exciting thing for this, from my perspective as a biodiversity scientist, is that this opens up rapid biodiversity assessment across all sorts of environments for types of organisms that have been exhausting to survey any other way. For many types of organisms, we can technically survey them, but you need such an array of experts in order to be able to do that satisfactorily. We need more rapid ways to be able to do it to achieve those results in a meaningful time period. I think environmental DNA will really help with that. It's probably going to be most exciting to begin with in aquatic habitats, particularly fresh waters and marine systems and so on. But my guess is it will also be extended to things like, as I show on the right here, meta-barcoding of pitfall traps as well. This is clearly heading in the same way as we were talking before about this digitization of specimens, heading towards those major data aggregators like GBIF and so on. I think in this area, this is clearly heading towards a very large-scale biodiversity genomics and aggregation of this type of data. And in the same way as I showed GBIF before and a series of other projects, this is a similar slide for that. Big projects are now starting to emerge, such as the Earth Biogenome Project, which are now pulling on a series of other projects to be able to create enormous libraries, if you like, for genomic information, and to be able to link that back to biodiversity studies. Now, I use the word library consciously there, because I think that if you think about the Biodiversity Heritage Library and what it's done for printed materials and art and so on, I really see strong parallels between that and the type of information library that GBIF is creating and the type of genomic library that these sorts of projects will create over the next few years. And clearly my push is for these things to be strongly linked from as early as possible, so we don't have to retrofit them together. There are other big advances in technology out there as well, and of course some of these are particularly relevant for what I'll be doing over the next few years when I move to Cornell. To begin with, there is now what I would call very large-scale citizen science. This map here shows you some of the results from using an application called eBird. This is probably now the biggest citizen science project in the world. It uses modern technologies to allow communities and individuals to record their observations on birds. That's all brought together, and you can now lay pretty sophisticated analytical tools on top of that. There's lots of user interface information available for these sorts of applications now. So for example, you can see what the bird looks like, you can read its habits, you can listen to its song, and so on. The point about this is that this is now the biggest biodiversity database in the world. And the rate at which this is growing, if you talk about tipping points, it's taken a few decades for eBird to get to its kind of first billion records. But as it will now start accelerating through that and start repeating that relatively more frequently. So this is a huge growing area for biodiversity science. And I think, again, it's very important to be able to link into this sort of data. It's more messy, but it's also analyzable. Artificial intelligence is one of the breakthrough technologies for to being able to use this type of information. iNaturalist, which again, I suspect many of you will be familiar with, is a great example of this. If you go out now for a walk with family or friends, you can often encourage them to take a photograph of an insect or a plant, something which they may not previously have known how to identify. And iNaturalist will give them suggestions for what it may be, and will also give them the beginnings of some information to take them off into other areas of information. These sorts of apps, I think, are opening up citizen science or community science for people that weren't previously thinking about it. I also think it's going to be possible to use these sorts of apps to encourage schools and so on to do biodiversity studies when they don't necessarily have the expertise in the school to do this sort of identification to begin with. I think that this will encourage the children and the teachers to have more confidence to take on those sorts of projects. It gets really exciting when we think about things like using a combination of citizen science plus automated recording plus artificial intelligence when you think about bioacoustic monitoring. The idea here is that you don't even necessarily need people to be there all the time to make the observation. What bioacoustic monitoring does is it leaves an acoustic monitoring device in the environment for a very long period of time and records the soundscape that results from that. And you can imagine that's a huge array of different sorts of sounds. The cool thing about the artificial intelligence we were just talking about a few minutes ago is now you can use that sort of technology to look through those long sound recordings and try to figure out which species are in there. Not just for birds, although the algorithms are fairly advanced for birds, but you can also start applying this to different sorts of insects and so on. Now, the point of this is that these recording devices, as you see, are very robust, and we're trying to push the price of them way down. So the idea is that if you were wanting to go out and record which birds or insects are in a particular area of forest, for example, this example here is from Peruvian forests, then you don't just have to rely upon being able to observe those individual birds and have a team that can do that. A team of foresters can put out a set of acoustic monitors like this and actually get a pretty good idea of which birds are in there. Again, there are biases in this type of data, as some of the data is messy. So one always has to be careful how you interpret this type of data. But if you go all the way back to that first example that I used of the German citizen science insect decline data, a lot of this data has challenges of that type. And I think one of the things that we have to take on is how to bring these different sorts of challenging data together to make an impact on decision makers and broader society. So I'm excited about being able to do this in forests around the world and find out even more about what's happening to biodiversity in those areas where there aren't lots and lots of citizen scientists or professional scientists to do that work. And coming towards the end now of the technology section, there's also very rapidly advancing technologies for how we look at how birds move across continents and even between continents. Again, I'm using a couple of bird examples here. The figure on the left here shows movements of a number of individual cuckoos, which happen to breed in the UK, move across Europe and into Africa for the northern wintering, non-breeding period. This study was led by the British Trust for Ornithology. Now, again, there's a few interesting things about this to me. The first thing is that being able to demonstrate live, this was done through radio telemetry, little radio transmitters attached to these 5 birds. The interesting thing to me about this was, first of all, that technology, being able to watch birds live go across 2 continents like this. The second thing was the power of this linking, I think, particularly in the minds of British people, how the health of their biodiversity, if you like, was closely linked to what was going on in other parts of the world. These cuckoos moving across continental Europe, across the Sahara and into the Sahel. I think it really brought home that these things are linked across all of those areas. The other exciting thing about this was the way that this was picked out in the media and repeatedly referred to as a kind of pioneering science study. I remember listening to the BBC one morning when I was driving into the Natural History Museum in London, and they asked one of the main presenters of the Today programme what he had been most excited about over the last year of reporting the news. He actually picked out this study, and he said that for him, that combination of technology, cross-continental impacts, and of course biodiversity really moved him to think in a different way about biodiversity and what lay ahead. I think that's important to be able to move people in that way, exactly like the insect study did at the beginning. Now, of course, we can do this in all sorts of ways. One of my favorite apps at the moment as we go into the migration season in North America is this one, Birdcast. But what Birdcast does is it uses the radar systems in all of the different North American states. And it takes the data that they're receiving at night and tries to predict how many birds are moving through the different areas of North America. At this time of the year, a lot of birds are moving through from South and Central America, either into the US or through the US into Canada. Now, the numbers involved can be absolutely mind-boggling. You can get hundreds of millions of birds moving through a year. And one of the points for somebody like me, it's simply fascinating to see how they're moving and also know which morning to go out and try to see as many of these birds as possible. But the deeper reason for doing this is to be able to then try to prevent casualties with these birds, because many of these birds are strongly attracted by lights at night. And when you're flying over North America, there are many cities with bright lights shining. That brings the birds down into those cities, and you get thousands and thousands of collisions each night. The pavements can be covered with dead birds. Through showing this sort of data and the impact of bright lights on the mortality of these birds, which many North Americans love deeply because they herald the beginning of spring, entire cities now are starting to turn out the lights at night during these peak migration days. So if you like, cities like Texas and Houston have just started doing this as well. They look at this data, figure out when the birds are going to be coming through, and they ask the corporations across those cities to turn out the lights so the birds will continue their flight to their breeding ground and aren't brought down into a very dangerous urban environment. I think that's an amazing connection between society, technology, and conservation. Okay, well, let's turn to the third type of tipping point that I was talking about, social tipping points. I don't think anybody on this call today will have missed the fact that COVID has changed the way that people are engaging with nature. Far more people are getting out into nature. People are more involved in things like bird watching, but all sorts of natural history activities. Also, because so many children are being homeschooled or doing remote school or doing remote learning, there are lots of K-12 educational products, so school learning products that are involving nature and involving citizen science type activities. And even beyond school children, there are lots of lifelong learning activities that are really being accelerated by COVID. So going back to the Cornell lab again, it runs a scheme called the Bird Academy for people to learn more about bird watching and birds and so on. That has had an enormous upkick in the number of people wanting to do that during COVID. It's really kicked off, I think, a connection with nature, partly perhaps because we're all away from our workplaces, but probably also because we can see small changes in nature around us. And that has made us more conscious of the impact that we have upon nature and on the rhythms of nature. At the same time, of course, that we have all lived through COVID, of course, there's also been an increase in environmental activism. This picture on the left here is from a relatively recent Extinction Rebellion protest. The picture on the right here is another tipping point, for me at least. This was a picture of a seahorse with a cotton bud in its tail that really, I think, brought home the issue of ocean plastics, not only to society, but also to politicians. I remember talking to one of the British environment politicians in the Natural History Museum in London. And I think it was actually seeing this picture and a similar picture with a turtle enmeshed in some ocean plastics that really made that politician want to push for better control of plastics within British oceans. So I think there's more environmental, that people are engaging with nature more, they're becoming more active more active with respect to environmentalism. And I think this gives us a platform to try to bring people into the debate about biodiversity declines. Of course, at the same time, there's a strong polarization of views on things like climate change in the environment. This graph here and this map here in the middle shows you something I suspect that people from around the world are familiar with, in that there's great polarization, particularly in North America, about the percentage of adults who think global warming is mostly caused by human activities. You can see that around the left there, many of the Democrat leading areas tend to believe that climate change is happening and that it's impacted by humans, where many of the blue areas in the more red states, if you like, the more Republican states, much lower percentage of people believing that. I think this is one of the major conversations that we need to engage with as biodiversity scientists. And I think that BHL has an important role to play here, because I think that resources like BHL can potentially overcome this type of polarization, because it's not seen as a polarized platform or polarized material. People are interested in BHL type material. So let's use it to overcome these sorts of barriers to conversation. And of course, it will be impossible to give a talk like this at the moment and not mention alongside the environment and alongside technology breakthroughs, but to talk about social tipping points with respect to racial justice and engagement with nature. This picture here is from my hometown at the moment. This is one of the Black Lives Matter protests in Washington, DC from the end of 2020. So it's had an enormous impact on society here as it has around the world. The other thing that of course has happened is that this has also translated into environmental work, biodiversity discussions and so on. In some cases, that's because of racism in natural history. So the Christian Cooper incident in Central Park illustrated that. But I think, again, it's also led to an activation of more diverse communities, pushing positively for change in what we do. For me and for BHL, I think there's a strong message here, in that when one looks at images like this, so most of you will know that this is John James Audubon in the top left there. This is one of his famous illustrations of a roseate spoonbill. This picture hangs over my dining room table. When you look at this picture now, I think it's impossible to look at it just as a beautiful illustration of a bird in North America. One can't look at this now without also thinking about what else was going on in North America at that time with respect to slavery and so on, and the impact that that has subsequently had on everything that's happened in North American society. And I think this is something that we are going to have to tackle. I don't think it's possible to be simply neutral on this. Neutral isn't going to be an acceptable position on these sorts of debates. And organizations like the BHL, the Smithsonian, Cornell and so on are going to have to take on this debate and be proactive in this debate. So I'm conscious of the time, so let me close by saying what I think this means with respect to tipping points for BHL. I think that each of these three areas have messages for BHL. With respect to the environmental tipping points, I think that BHL can play an incredibly important part, not just in documenting change, but also setting up what I would call an Earth optimism narrative. You can see that in lots of the examples I've used here, I've tried to link technology with data with societal change. And I think that the sorts of material that BHL curates and makes available and links with across the world is really open for this type of an Earth optimism narrative. I think also there are some messages from this type of analysis for what comes next for BHL with respect to technology. I think the obvious thing is that extended specimen framework is going to be really, really important. I think that making sure that literature and art resources are linked into that data is going to be key for making sure that BHL continues to be a highly used resource. I think it's also going to be important to link to new sources of data, the genomic information that we talked about, and particularly the citizen science data. The citizen science data is now creating huge amounts of information, lots of people taking part in that. Let's link that. Let's make sure that's closely linked to things like BHL as well. And then lastly, on the right here, this again is Audubon's Carolina parakeets. I think it's vital that BHL uses its power and its resources to engage new audiences in these types of debates and directly tackles the colonial history of natural history. I know that Lydia is going to be talking at the end of today's session about that, and I would endorse the view that we need to tackle this in a proactive way. Okay, Connie, I will hand back to you now, and I'll stop sharing my screen. Thank you very much for giving me that time to talk about tipping points in biodiversity.
Thank you so much, Ian. There's so much in your talk that is really important, and we have a number of questions, so I'll just dive right in. The International Biological Program of ICSU from 1967 to 1973 gathered a huge amount of site-specific biodiversity data worldwide, but it is still locked up in paper records. Making this available would provide invaluable data to monitor change. How can we ensure that the paper data sheets held by institutional repositories are made available?
Great question. I mean, and this I think broaches the broader question of, we know that particularly in the area of biodiversity, because that science started, as this question highlights, some time ago, it wasn't a born digital science. It was a born analog science. So we face this mountain of historical data. And I think that's been off-putting for us in some cases. I think that the fact that we have these huge historical collections of information has made us a little leery about trying to digitize it and make it available. My personal instinct on things like that particular repository is that we need to make the case to digitize this, and we need to bring in both governments and corporations to help us being able to do that. I think we have to make the project sound exciting. We have to say that we have these amazing time machines on what's happened in the past. But then we need to say, you know what's going to unlock this? It's going to be a combination of AI and new types of approaches and so on, and say, let's exploit these new technologies to unlock these vaults of information about the past. When I've tried to do that in the past, I think what I've typically found is that a lot of those companies are most interested in the sexy bit to do with analyzing the data. And I think that's one of the reasons why I find BHL such an interesting platform. I think one of the cool things about BHL is it can demonstrate that it isn't all just about the analysis. Some of these resources are either beautiful or intriguing in their own right, and therefore we can give a purpose to releasing them to the world.
Great, thanks. Here's another one. eDNA analysis certainly holds great potential that we're starting to tap into, but there are consequences for collections. What do you think it will mean for collection management in museums when the specimens are water or soil samples rather than what we traditionally think of? What will the challenges be for museums to store these samples? And is it even possible to meaningfully use them for display?
That's a very relevant question for what we're thinking about at the Smithsonian at the moment. Absolutely. I wish I had the answer to all of those questions. It's exactly the right set of questions. What my perspective is at the moment with respect to eDNA is, I think you're right, it will radically change, or has the potential to radically change how museums work with respect to curating their specimens. I think we have a choice ahead. We could avoid these sorts of specimens and stick with traditional kind of object-based collections, or we could embrace environmental collections. My view, you can probably guess what my view is. My view is that we should embrace environmental collections, but we need to be really careful how we do that. What we're trying to figure out at the Smithsonian at the moment is what the consequences would be of bringing in, of creating major environmental collections, what that would mean with respect to infrastructure, and what that would mean with respect to staff expertise and so on. And you're right, they're profound. My guess at the moment is that, say, North America is challenging in this respect because it has a statewide state sort of structure. But my feeling is that we're going to need to create regional repositories for this type of information. In some cases, storing the original environmental sample because we think there's value in the sample itself. And in other cases, not storing the original sample, just doing the extraction and processing of that. But that's going to be a massive change in how we work. When it comes to the display of these sorts of specimens, I think we're going to have to be you're going to have to be cunning in the way that we display, or imaginative in how we display these sorts of specimens. I don't think individual environmental specimens are going to replace, some, if you think about, some amazing from London, a blue whale skeleton, or here in the Smithsonian, an African elephant or something like that. That has a different type of inspiration. But I think that it might be possible to try to do arrays of environmental samples and try to communicate what these things look like and the type of information in particular that we're extracting from them. But you're right, it's potentially a major game changer for museums, and we need to make the decision about whether to take it on, particularly when we already know our resources are very, very stretched in many ways.
I should say that question came from Ellie Wallace.
Okay.
And the first one was from Gina Douglas.
Okay, that makes sense.
So yeah, probably helps you to put it in context, I tell you. This one's from Diane Rielinger at Harvard. What do you think is the biggest challenge to connecting primary literature and archives, such as that in BHL, to digitize specimens in an extended specimen network?
I think the biggest challenge is probably cultural at the moment. I think that, so in my sort of role where I'm often in the same day talking with, let's say, the libraries group, the entomology group, the anthropology group, and maybe an information technology group, it often strikes me that the main barriers for that particular link are not really with respect to the technology. I think we have the technology to do a lot of the interesting work. I think one of the issues really is that at the moment, the BHL and the library and archive systems are actually probably decades further advanced than our equivalent systems for some of the other types of organism. And I think that for some of the other groups at the moment, or some of the teams looking after the other groups at the moment, they are at the moment kind of trying to construct what might be the equivalent of BHL. So when it comes to thinking about linking that to apparently another information source like BHL, that isn't top of the list, because it feels like we have to build our car first before we can connect it with your car. I guess I don't agree with that. I think that for a couple of reasons, I think it's absolutely crucial to link those two things. And I think that actually, if you're an ornithologist and you're trying to figure out how to collate all the information in the ornithological collection, there's nothing more useful than looking at what's happening either in, usually it's either with respect to libraries and archives or with respect to herbarium collections. They tend to tell you the most robust ways of doing that. So I think it's cultural at the moment, and making sure that the literature and the archival and the art materials are always included in those big projects like ID Bio, Atlas of Living Australia, BISCO, and so on. They need to be in there right from the start because they're important and they have so many lessons to tell. I also think that the way that BHL has managed to construct a community in terms of paying for itself, if you like, and becoming a service in some ways, is really important for how these other types of repository will persist in the long term. So cultural, not technology, culture.
From Alejandro Bortolas, technology is not homogeneously developed nor used across the world. And there are vast regions where people keep struggling to have basic tech services like internet or even mobile phone service. This worldwide regional inequity may lead you to think that a lot of technological monitoring you show is functional mostly to developed countries alone. What would you recommend to revert or change this trend and belief?
Very good point. I think that with respect to some of the technologies that I've spoken about there, And I was chatting about this just actually yesterday with respect to the bioacoustic monitoring example that I was using there. That I think that we need to, it's very tempting if you're working in an organization like the Smithsonian or the Natural History Museum in London, just to push hard on the technology and analytical part of it. I think that in the future, what we need to do is when we're pushing for these new technologies is to do an equal investment, or at least an equal investment, not just in developing the technology and the cutting edge research, but also in making sure that it's actually possible to use this in exactly the places that you're talking about there, where there can be limited resources, limited training opportunities in some cases, and limited access to things like the internet. So I think that we need to, again, build those into these projects right from the beginning. On some of these things, I think there's now the opportunity to do that. But it's a little bit like the decolonization debate that I suspect we're going to have throughout the rest of the day. This needs to become a deep part of the culture of these sorts of organizations that currently have the money and the data and many of the resources to make sure that this actually has an impact across the broader global community. It will take investment, and say in the case of that bioacoustics piece, it will take equally ambitious, if you like, capacity building programs as there are technology or research programs.
Thank you. Here's one from Helen Peathers. Hi, Ian. Greetings from the Natural History Museum Library. Copyright has a big impact for libraries in making more recently published materials available in BHL. Do you have any opinions about copyright and how this can be improved?
This is a dangerous call for me to talk about copyright. I think
Sorry.
everybody on this, you guys probably know a lot more than, yes, clearly a big issue. So I'm, on this one, I guess I know more from a scientist perspective than I do from an expert copyright perspective. I think that an encouraging sign, from being positive about this, an encouraging sign is I think that this issue is now far better appreciated amongst practicing scientists than it would have been a decade, certainly 20 years ago. So I think we need to continue hard the push for people to make non-copyright materials available in repositories and so on. And we build up the systems to link from those into things like the sort of data aggregators that we're talking about. I think that people see the equality problem there pretty starkly. So I think that we can get the next generation of scientists to do that. I think we can encourage them to be less obsessed with publishing in big publisher journals where copyright is very difficult to navigate, and get them using repositories a lot more. I love the idea that so many of our libraries are building their own repositories to put that sort of material into.
What are the tipping points to how disciplines will operate in the future, especially the historically segregated natural sciences and humanities? Are natural history museums ready to employ historians of colonialism?
Wow.
Bohi.
I think I would go so far as to say, if we don't do those two things, if we don't bring nature and people, if you like, closer together, and we don't directly address things like the history of colonialism and so on, then I think that's an existential threat for these sorts of organizations. We are so built up, particularly in the Northern Hemisphere and Europe and North America. We are so built on that culture and that period of time over the last couple of 100 years. Unless we address that, I think that really puts a threat to what we can do for society. So I think that we have to do that. As I've said, that for me at least, when I'm interpreting objects or art or something like that, I think it's become impossible for us to do that without taking those things into account. And yet we're not equipped to do that. I'm not an expert in those areas. I need colleagues around me to do that. And I think that will become, I think that will be seen in the hiring practices of these institutions now. It will take a little bit of time, I think, but I think that it's an urgent matter, and as I suspect you will discuss later today.
And as kind of as a follow-up to that, and this is really from the BHL, a question from the BHL, can Indigenous knowledge help fill data gaps in natural history collections, and what strategies can help us discover and incorporate that Indigenous knowledge?
It surely can. I think that in the studies that have been done that include that type of knowledge, what I always find when I see those sorts of studies, it's not just the knowledge that adds so much. It's also that hearing those personal narratives and hearing those narratives spoken, sometimes in the Indigenous language, sometimes in other languages, is incredibly powerful. And it's another way of providing positive narratives and helping people reflect upon where we are now, and that break there often is in modern Western society between nature and people being seen as very different things. So many of these narratives bring nature and people together deeply. So I think that it's a very powerful approach. I think at the moment it's limited the extent to which we've done it. I think the only way of doing it satisfactorily is we need much deeper partnerships with those communities. Again, there's been a break there quite often, or we've kind of we've used Western science methods to try and understand them. I think we need a much better relationship directly with communities, and that's not simple or easy, but it's again another challenge that we need to take on.
Okay, a question from Tomoko Steen. Increasing interests on microbiome diversity among a variety of species is in question. Would museums or biodiversity scientists expand research on microbiome diversity parallel to species diversity?
These are a good set of questions. These are absolutely going down the list of topical questions for museums at the moment. I think the quick, easy answer, if you like, is yes. I think a lot of museum scientists are really interested in microbiomes and would love to get into them. And they realize also that their specimens are potentially relevant for some of those studies. I think one of the challenges is that not many museum scientists have a great knowledge of bacterial systems and some of the types of techniques that you use to study microbiomes. So almost the best studies I've seen to date have typically been through partnerships between museum scientists and then scientists working in an institute where they have great familiarity with those sorts of bacterial systems. But I would strongly encourage those. I've seen some really exciting data recently coming out of that area, which I think will really, I think it's going to be an area where the next generation of kind of, proto natural history museum scientists are going to be really interested in doing that. So it's a great student attractor as well. I think that when it comes to collections, it's going to be interesting whether natural history museums get into microorganism collections, if you like. I know a lot of us have been quite cautious about that for another reason. So whilst I'm quite gung-ho, as you can hear, about trying to get into environmental samplings for eDNA, I am a bit cautious about us trying to take on microorganism collections because of our expertise.
Okay, well, there is actually one more question, but it's really pretty directly for the BHL. So I'm going to read it, but then BHL will take it under advisement. And then we'll close the session. So thank you, Biodiversity Heritage Library, for all you're doing. There's a growing movement for Indigenous data sovereignty over both digital cultural heritage projects and biological digitizations, global Indigenous data analysis, Merkurtu, etc. Local contexts have launched traditional knowledge labels as well as biocultural labels. The latter are applied to biodiversity data to flag Indigenous issues of permission, context, and protocols. Has BHL engaged biocultural labels for their collections? Thank you. And I will say we have not yet, but we'll take this into our knowledge base and see what we come up with. And now I'm afraid it is time for us to close this session. thank you so much, Ian, for all of the great insights you've provided. And we will now break for a half an hour, 30 minutes, and return for the partner reflection panel in 30 minutes. So thank you, everyone.